So let's say I'm a Disney person and I have an idea for like a theme park and I come to your company. Do I interact with you? What is it that you want from me? And after we discuss these requirements, how does the process look like afterwards?
Well, there's a whole bunch of options. If we talk about Disney rides, we have people called Imagineers that come up with the concept of what they want it to, how would they like the ride to incur.
Is that
And
something like a designer? I have never heard the word Imagineer.
Imagineer is specifically for Disney, I believe, because you're imagining, and so they call themselves Imagineers. So these are really artists and visionaries, and they come up with, for example, if they're designing a cartoon and they want that cartoon to come to life as a ride, they would convey to us what they would like to see happen. And they would have a storyline which they would outline this is what would happen at this part of the story, and these are the emotions that they would like to convey, and these are the thrills, the G forces that they like to see.
Mm-hmm. Are we talking about a specific, let's say, roller coaster ride or like a set of rides within a theme park?
We're talking about one specific
One
ride.
specific ride, okay.
Yeah. So, for example, we can go back to my ride, which is Soaring Over California. And the idea is that you're going into Everett Air Force Base and you're riding a flight simulator. And through that flight simulator, you're going over various parts of various parts of California. You see the orange groves. You feel the water coming, splashing up from you from the waves. You see the fine pine forests. So there are certain images that they would like, certain feelings, certain G forces, certain peripheral visioning that they'd like to see. And then you take that and you figure out how you can make that move.
So do they
within a
already
certain
give you
space.
kind of like a more specifics like about how the ride should look like, or is that part of your work and they just give you the rough concept?
They give you a rough box as to when you're at this area, you can move to this amount of location, and it's up to you to, for example, project the guests into the IMAX screen, how you think that's best approached. And it's up to you to figure out how do you create that swaying motion. How do you hide certain things that you don't want the guests to see? How do you get the smells to be blown in? And what kind of G forces are you expecting to see?
So we are talking about like the IMAX. Is it 4D experience or is it now 5D or 6D or
I don't know what you
water
would call
splashing
it.
from everywhere, right?
Yeah,
The
IMAX,
complete experience.
the complete experience. That's
Yeah.
right. Yeah,
So, okay.
IMAX is great.
Yeah. So now that you guys figure out like what the client wants, in this case Disney, what is it that you do afterwards, like internally with your team?
Well, we would sketch it out, and our team comprises of engineers primarily. For Disney rides, they're primarily engineers. For other, for example, buildings, you would need an architect. But if we're talking about Disney rides, it's a combination of steel, structural engineering, mechanical, and electrical, and how to bundle it together so that we're able to do what they want us to do. And then, of course, money is a big issue too, right? How much
It always
money?
is.
It
Are you,
always
are you
is.
saying it's not for free?
I'm saying more like how much is the budget so that what can you do?
Right.
And do you want leading edge versus bleeding edge, and we want
Whoa,
reliability?
That is
bleeding edge,
wait.
Sometimes you don't want to do something too new. You want proven technology, then because Disney rides are designed for 20 to 30 years at a time, and certain components are proven because you're running it, cycling it every 7 minutes for 18 hours a day, right? And then there are other things where you do want to have the technology, like the special effects and so on. But typically, when you're talking about mechanical electrical systems, you want systems that are proven so that you know when you're expecting it to fail, how long it's going to last, what's the reliability and the redundancy.
And after you have the sketch, which I think it's kind of like a design, what happens after?
Then you look at all the different components that need to be designed to put it together to move it. So, some of the secrets of soaring is that there is a carriage that is up on rails. So, once you figure out that you want it to run along rails, you need to figure out the vehicle and how is that vehicle going to be moving? What kind of tires? What kind of cabling? What kind of mechanism? So you break yourself into your specific disciplines, and then you figure out each part on how to get it to fit together.
And what happens between that and when the ride is actually open to public?
That's like 4 years down the
road. or like give us like a timeline. Like how long does this process
Lillian
usually
told
take?
us 1%.
That's 1%.
Oh man, it's like I can show you the drawings, and then we can work out each component part by part. What happens is that there's a lot of modeling, computer modeling. So you design it to look at the flow and the directional movement, and then from that you determine some stresses. So you're really starting from macro, from the large side, all the way down to the smallest sides. So when you're designing, for example, the ride mechanism, you're checking the loads for the vehicle path, and then you're checking for the various failure systems along the rail. You figure out if the ride stops at this point, what's going to happen to it, what kind of G-forces, is that going to fail the entire ride. So you go through various different load combinations, and then you go into the smaller components. So once you get the carriage in place, then you might want to start looking at the chairs, and the chairs are made out of steel, and you go through the various the testing again as to if you put a child on that chair or an adult on the chair, what kind of loads, what kind of failure you're going to see. And it just takes a lot of time going component by component. And ultimately, once you finish off the modeling, you design it for those loads. You size up the members for those loads. And then you would take a component. In our case, we took a third of one theater and built it and tested it over 10,000 cycles. So what that does is it's called a first article testing. It means that you are cycling it through 10,000 cycles through various different failure modes to see what the stresses are. You have measurements, you have strain gauges on the metal itself, and then you see if it correlates with your numerical calculations. Because typically when you're designing these type of rides, you design it for a lower stress range than you would for a building, for example. And then that way, over time, you know that the stresses are not going to fatigue, and you will have a safe building or safe system. So it's a little different in that you're testing and verifying. And once that's verified, you might make some tweaks. And after you do the tweaks, then you would start building it and then ship it and test it again. So there's a lot of testing that goes into it, modeling and testing.